Hello everyone. Today we are going to continue 8th class toppers program chemistry of carbon and nitrogen. Already in the previous session we have done with the single correct answer and conceptual understanding questions. So today we are going to start our session with multi correct answer type questions. Multi correct answer type questions means more than one answer. It can be one or more than one. In the given options one answer can be correct or more than one answer also can be correct. So let us start with the multi correct answer type questions. Okay, see here the given question: the crystalline allotropes of carbon among the following. So here they given some options. In these options he is asking the crystalline allotropes of carbon among the following. See, the given options are: first one is diamond, next graphite, third option is fullerenes, and fourth option is coal. See, diamond is a crystalline form of the carbon. It glitters, it shines, diamond, right? So this is the picture of the diamond. It is the crystalline form of the diamond. So crystalline form of the carbon, right? And also it is the allotrope of carbon. Diamond is the allotrope of the carbon, and also it is the crystalline form of the carbon also. Comes to the next option, he given graphite. Graphite is also one of the allotrope of the carbon, and also it is the crystalline form of the carbon, right? So we will go with the graphite. Next one, fullerenes. These are the fullerenes, and this is also allotrope of the carbon, and also it is also crystalline form of the carbon. So we will go with the C option also. And comes to the coal. Coal is this. It is not a crystalline form, right? It is not the crystalline form. What will be the crystalline form? Or salt, or table salt daily we will use in our kitchen, right? That salt is in crystalline form, like that it should be. But coal is not a crystalline form of the carbon, but coal is the allotrope of the carbon. Okay, but our question here, the crystalline allotropes of carbon among the following is. So I will go with the A, B, C options, not with the D option. Okay, let us see. Comes to the next question: the purest forms of carbon among the following. So he is asking the purest forms of the carbon, purest form, no impurities in that. So see what are the options are given. First one is the diamond, second one is coal, third option is coke, and fourth option is sugar charcoal. See here, diamond. Diamond is, this is the diamond picture, and this diamond is the purest form of the carbon, no doubt at all. So purest form of the crystalline form of the carbon is the diamond. So our first option is correct. How can we say it is crystalline like that? That's why here the pictures are showing how it will be. Comes to the next one, coal. See, coal means this one. It is not the crystalline form, purest form of the carbon. It has some impurities. It is not as pure as the diamond, right? So coal is not the purest form. It has so many impurities. Okay, and next one is the coke. See here you can observe coke. It also has the impurities in that. It is not the purest form, and only carbon also will not be present in that. The different types of minerals and other impurities also will be present in this coal and coke also. Comes to the sugar charcoal. See here, this is a picture of the sugar charcoal, and we can say it is also the purest form of the carbon. One of the purest forms of the carbon is sugar charcoal. It will be very smooth, and we can cut with this spatula also. Okay, so diamond and sugar charcoal both are the purest forms of the carbon, not the coal and coke, as they have impurities in that. They are not the purest forms. Comes to the next question: identify the correct sets of carbonates and their formulae. See here they given the sets, means name and molecular formula is given, and in the question they are asking to find out the correct, both are correct pairs or not, means CaCO3. Is this CaCO3 is named as limestone? The name and the formula both are correct or not is our question. Comes to the first one, limestone. limestone is also known as calcium carbonate, right? Calcium carbonate. See here, this is the limestone. This is the limestone. It is the calcium carbonate, CaCO3. So limestone and CaCO3. The molecular formula is correct for this formula. Okay. Now come to the next one, magnesite. For magnesite in the options they given CaCO3 and MgCO3. Sorry, CaCO3, MgCO3. Calcium carbonate and magnesium carbonate like they given. But magnesite is known as magnesium carbonate is also known as magnesite. There is no calcium carbonate in that formula. But here they given calcium carbonate also in that formula. So this is not the correct pair. For the given formula, it is not the name. Okay. See here, this is it like this. The magnesium magnesite means the magnesium carbonate will be looks like this white crystalline form. This is also magnesite. Okay. Comes to the next one. They given dolomite. See here, dolomite formula is wrong. Actually, dolomite formula is this one. CaCO3, MgCO3 is the formula for dolomite, and MgCO3 is the formula for magnesite. But here they given in the wrong pair. For magnesite they given dolomite formula, and for dolomite they given magnesite formula. So even C option is also not correct, right? Comes to the next one, calamine. See, the calamine will be like this. This is a smooth paste like it will be, and the formula for calamine is zinc carbonate. This is the zinc carbonate lotion, like calamine lotion, like that. When if we have any rashes on the body, generally they prefer to use this type of calamine. So it is the zinc ZnCO3 is the correct formula for calamine. So D option is also correct. So in the question, identify the correct sets of carbonates and their formulae. Limestone is the correct formula, means correct pair. Magnesite is wrong, and C option is also wrong, and D option again the calamine ZnCO3 is the correct pair. Okay. Comes to the next question. The important natural sources of carbon compounds is or are. See here, they are asking in the given options which of the following are the important natural sources for the carbon compounds, they are asking. See here, first let us check what are the given options here. See, first one is coal, and second option is petroleum, and C option is ammonia, and D option is water. Let's check here. Ammonia is NH3 and water is H2O. The question, the important natural sources of carbon compounds, these two are not at all the carbon compounds. Ammonia is completely different, it is not a carbon compound, and water, it does not have any carbon particles or any carbon atoms present in that. So these two are wrong options. Let us check the coal and petroleum. Yes, coal is the important natural source. How we will get the coal? When we are burning the box of the tree or anything, if we burn we will get the coal, isn't it? That is also one natural source of the carbon compound. Like that only petroleum also. Petroleum is also another thing. Like this the petroleum will be, and it is the coal. So these two are the natural sources of the carbon compounds, not ammonia and water. So we will go with the A and B. Okay. Let's see the next question. The allotrope of carbon that is used in nuclear reactors. See, whatever we have here, all these are the allotropes of carbon only. Let us see in the first option. First option is graphite, second option charcoal, third option coke, and fourth one is lamp black. So these four options are allotropes of carbon only, but out of these four, which one they used in nuclear reactors is our question. So generally in nuclear reactors they use the graphite, this graphite. This one they will use in the nuclear reactors, not the remaining. Charcoal they will not use, coke they will not use, lamp black. also they are not using. So graphite is the allotrope is used in the nuclear reactors. Okay. Comes to the next question. Which one is an ammonium salt? So here some salts are given in the options. He is asking which one is an ammonium salt, right? See here, NH4 taken thrice PO4. This is ammonium phosphate. This is ammonium phosphate. The name of this compound is ammonium phosphate, and this is the salt of ammonium. Ammonium salt, right, means there is no H plus and OH minus ions, two ions, one cation and one anion, they will combine and they will form the salts generally, in general if we consider. So here NH4 thrice PO4. So NH4 thrice PO4 is ammonium phosphate and this is the ammonium salt. Comes to the NH4NO3. This is ammonium nitrate. Ammonium nitrate is also the salt of ammonium. Ammonium nitrate is also the salt of nitrate, right? So we will go with the B option also. Comes to the Na3PO4. This is called sodium phosphate. In this molecular formula there is no ammonium. So this is not the ammonium salt. This is sodium phosphate. This is the sodium salt, not the ammonium salt. So C is the wrong option for the given question. Next one is NH4Cl. NH4Cl is ammonium chloride. So it is also the salt of ammonium. So ammonium phosphate, ammonium nitrate and ammonium chloride, these three A, B, D are the correct options for the given question. This is the salt of sodium. That's why we are not choosing C. Okay. Comes to the next question. Ammonal is the mixture of, see here, this is the ammonal generally. This ammonal will be the mixture of, the given options are NaNO2, ammonium nitrate, sodium nitrate, ammonium nitrate, aluminum powder and magnesium powder. Generally ammonal is the mixture of ammonium nitrate and aluminum powder. These two will use for the preparation of the ammonal, not sodium nitrate. Ammonal is a mixture of ammonium nitrate and aluminum powder, not they are using the magnesium powder. Okay, so we will go with the B and C options. It is the direct, it is the mixture of both ammonium nitrate and aluminum powder. That combination is called ammonal. How we are calling water gas CO plus H2. Like that, this is also the mixture, aqua regia, like that we have a different mixtures. This is also one of the mixture. That mixture is the combination of ammonium nitrate and aluminum powder. Okay, comes to the next question. The acids used in the preparation of aqua regia are, see, aqua regia, it is the combination of, see here you can observe this is the aqua regia and this is also known as the king's water like, and it is the combination of concentrated HNO3 will be in one part and HCl will be in three parts. If you are taking one ratio of HNO3 and 3 parts of HCl and making the mixture, then that is called the aqua regia. Okay, the acids used in the preparation of aqua regia, first one is hydrochloric acid is given, next nitric acid, sulfuric acid and water. Here water is not at all the acid, so we will not go with the D option. Next HCl, HNO3, H2SO4, but here it is clear aqua regia is the combination of 1% of HNO3, see 1% of HNO3 and 3 parts of HCl, both will make the aqua regia mixture. So we will go with the A and B options, not H2SO4, because sulfuric acid we are not using for the preparation of aqua regia. Okay, comes to the next question. Ammonia is very important. Let us check the options. From the options we can get the answer for this question. Ammonia is very important for what? Let us see the options. Compounds of nitrogen, yes, and alkaline gas, third option is NH3 and fourth option is acidic gas. See here, NH3 is itself, it is called ammonia, right? So ammonia is very important to ammonia, it cannot be. So we can cancel the C option, right? Comes to the ammonia is very important acidic gas. Actually ammonia is a basic in nature, not the acidic gas, right? It is basic in nature. That's why even not the D option. Comes to here compounds of nitrogen. Yes, ammonia, formula for ammonia is NH3. It is the compound of nitrogen because here one nitrogen and three hydrogens are combining and forming the ammonia compound. So it is the compounds of nitrogen. And see, it is a alkaline gas. Alkaline is means base. So it is a alkaline gas. Yes, NH3 is basic in nature, so we can say it is an alkaline gas. So the given question, ammonia is very important compound of nitrogen and it is a alkaline gas. It cannot be NH3, very important to NH3, it cannot be, and it is not acidic gas because NH3 is basic in nature, right? Okay, comes to the next one. See, till now we have completed the multi-correct answer type questions. Now we are going to start with the comprehension and passage type question. What is this comprehension and passage type question? They will give one passage and they will frame the questions from that passage. By using the passage we have to answer those questions, right? See, the given passage, a solid non-metallic element X. They are giving the about the X. This X is a solid and non-metallic element. One solid non-metallic element X burns in atmospheric air. So atmospheric air is nothing but oxygen only. So X is a solid non-metallic. This is burns in present in the air, in the atmospheric air, to form a mixture of two oxides. Those are Y and Z. Suppose they are forming two oxides. We don't know what are those also. So those are Y and Z. Y is a poisonous gas. This Y is the poisonous gas. And Z turns lime water milky. And this one turns lime water milky. So here, by these properties, we can conclude that what is that solid non-metallic element? Non-metals is nothing but we can take the compounds from fourth group, right? Fourth group means carbon, nitrogen, oxygen and fluorine. These are the non-metals. This is the fourth group, fifth group, sixth group and seventh group. Let us take the first one. If you take the fourth group elements, first element is carbon, right? If you think this first one is as the carbon, then carbon on combustion, right, means oxygen reacting with the atmospheric oxygen, it forms two oxides, then it can be carbon monoxide and carbon dioxide. Actually carbon monoxide is poisonous in nature and we know this carbon dioxide turns lime water milky. Carbon dioxide has that nature itself. So it is a carbon dioxide turns lime water milky. So for X, carbon is suitable. Let us check even for the fifth, sixth and seventh group elements also. See, if you think a solid non-metallic element X is like N, means nitrogen. Nitrogen burns in atmospheric air to form mixture of Y and Z. Suppose nitrogen on combustion, it forms Y and Z, two oxides. But suppose it is forming a nitrous oxide, nitric oxide, any oxides if it is forming, those are not the poisonous gases and they will not turn lime water milky. They don't have that properties. So it cannot be nitrogen. Comes to the oxygen. Oxygen is burning in the oxygen, maybe it forms some of the oxides. If it forms oxides also, it cannot be a poisonous gas and it cannot turn lime water milky also. And even fluorine non-metal, if you take fluorine, chlorine, the fluorine oxides or chlorine oxides, if anything you take, those also cannot be the poisonous. So it is clear from this paragraph, a solid non-metallic element X means we can consider as carbon. This carbon bonds in atmospheric air to form a mixture of two oxides. First one is Y and Z. Maybe it is carbon monoxide and carbon dioxide. Y can be carbon dioxide and Z can be carbon monoxide also. Okay. But see the next one. Y is a poisonous gas. Y must be carbon monoxide. It cannot be carbon dioxide because carbon dioxide is not a poisonous gas. That's why Y is carbon monoxide. And Z, it turns lime water milky. Carbon monoxide will not turns the lime water milky. It doesn't have that property. It is a poisonous gas. Carbon dioxide turns lime water milky. So compulsory, there is no confusion in that. Y is compulsory carbon monoxide and Z is carbon dioxide. This is the data we have from the given paragraph, right? So let us see the given questions. The element X is, see here, the element not nitrogen, already we discussed this one. It cannot be hydrogen because hydrogen is reacting with the oxygen, it forms water. That water is not a poisonous gas and water cannot turn lime water milky, right? So even B also wrong and oxygen is also wrong. Oxygen itself, it cannot form its oxides, it can form the ozone O3 like. So it cannot be D also. The given correct option is carbon. Here is the carbon, right? Comes to the next question. The compound Y combines with the hemoglobin to form. What is actually the compound Y? You can see here the compound Y is clear here, that is carbon monoxide. When carbon monoxide combines with the hemoglobin, see here, this is hemoglobin when combined with the carbon monoxide, then here we have a different properties about this one. See, hemoglobin, it is 200 times more affinity to carbon monoxide than oxygen, means it can react fastly than oxygen than carbon monoxide, and carbon monoxide is a colorless, odorless, tasteless and more affinity, means it is willing to react with that faster. Here hemoglobin is 200 times faster willing to react with carbon monoxide than oxygen, right? So carbon monoxide, these are its properties. When these two are mixing, as hemoglobin has more affinity towards the carbon monoxide, they will both combine easily and they forms the carboxyhemoglobin. They forms carboxyhemoglobin. So here the question, the compound Y combines with hemoglobin to form. First option is hydroxyhemoglobin, no. Second option is carboxyhemoglobin, yes, it is correct. And next one, alkoxyhemoglobin, no, it is not reacting with any alkane and it is not reacting with any oxygen. If it reacts with oxygen, then oxyhemoglobin. It reacted with carbon monoxide, so we can call that mixture as, we can call that as a carboxyhemoglobin. We will go with the B option. Okay. Comes to the next one. The nature of Z is, see here, what is the Z here? It is clear Z is carbon dioxide. Carbon is a non-metal. Generally what we can say, non-metallic oxides are acidic or basic? Non-metallic oxides. Metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. And even in the periodic table, if you consider left to right, non-metallic nature increases and metallic nature decreases. First group and second group elements are metals, metallic in nature, strong metals those are. Whereas they are moving from left to right, the non-metallic nature increases. And first and second group elements are basic in nature, and when left to right if you are moving, then acidic character will be increases. So those are acidic oxide. Carbon dioxide is a acidic oxide. So A, acidic oxide, not the basic oxide. Sorry, it is not a neutral and it is not amphoteric. Amphoteric means both acidic and basic, but it is clear carbon is a non-metal. Non-metals will be acidic in nature. That non-metallic oxides, we can say those are acidic oxides. Metallic oxides are, it is clear, those are the basic oxides. Okay, so it is acidic in nature. So first passage and the questions. Okay, first passage and questions we have completed. Let's come to the passage 2. In comprehension and passage, and we are going to the next passage. Let us see here what is the passage given. Nitrogen is chemically inert under ordinary conditions. However, it shows chemical activity under high temperature. So, the data giving nitrogen is chemically inert. Inert means it is not more active. Okay, it is stable like. It is chemically inert under ordinary conditions. Means at room temperature, if you consider, that is not super reactive. That is just in ordinary, means that is a chemically inert in nature. However, it shows the chemical activity when it increases its activity. When we are increasing the temperature, under high temperature, nitrogen increases its activity unless it is chemically inert under ordinary temperature. So, this is the passage they have given. Let us see what are the questions they are posing. See the first question. Nitrogen reacts with hydrogen at high temperature in the presence of catalyst to form. This question is clearly called Haber's process. Haber's process means Haber's process is the preparation of ammonia. Okay, so in that nitrogen, see here, making ammonia, the Haber's process, N2 plus 3H2, nitrogen reacts with hydrogen, forms ammonia. This is called Haber's process, but this ammonia formation will not happen at ordinary conditions. We have to use some conditions, means we have to maintain the pressure conditions, we have to maintain temperature conditions, and we have to use the proper catalyst. Okay, and promoter also we have to use, then only this ammonia will form from N2 plus 3H2, and then we can call that phenomena as the Haber's process. Okay, let us see what is Haber's process in this flow chart. Nitrogen from the air, hydrogen from the natural gas, both will combine by 1:3 ratio. N2 reacts with H2, forms NH3. This reaction is not balanced here. 2 nitrogens we have, but here only 1 nitrogen. Here 2 hydrogens are there, but the product side 3 hydrogens are there. If you balance the equation, here you have to keep 3, then 2 nitrogens 2. Then 2 nitrogens, 2 nitrogens. Nitrogens are equal on both reactant side and product side. Comes to the hydrogens, in the product side hydrogens are 6, 2 3 is 6. But in the reactant side, if you take H2, hydrogens only 2. So, to balance that we have to write 3 here. So, now the given equation is balanced. N2 plus 3H2 gives 2 NH3. So, after balancing the equation, if you check here, nitrogen is in 1 ratio and we have taken hydrogen is in 3. So, 1:3 ratio. In the Haber's process, we are using nitrogen and hydrogen 1:3 ratio by volume. Gases we are mixing, not the solutions. So, here we are mixing by volume under 450 degrees Celsius temperature. Compulsory we have to maintain the temperature 450 high temperature, and pressure is 200 atmospheres pressure, and here we will use catalyst iron. Iron is the catalyst. What is the work of the catalyst? This catalyst will not involve in the reaction, but it speeds the rate of the reaction. It speeds the rate of the reaction. Okay, so that is called catalyst. If you apply these conditions, then this nitrogen and hydrogen will combine and will form the ammonia. So here at the temperature in the presence of a catalyst, it forms ammonia. This is called Haber's process. Let us check what are the given options. They given nitric acid HNO3. So N2 and H2 combining at high temperatures will not prepare nitric acid, right? Next, ammonia is the correct option. Again given nitric acid, not C option. Nitrogen dioxide NO2 will not be prepared by using N2 and H2. We cannot prepare NO2. Is it clear? Because in the reactants there is no oxygen. How it can be in the products, right? So the D option is also wrong. We will go with the first option. This is the first passage question, right? Comes to the next question. Which conditions are stable for the production of ammonia by Haber's process? Which conditions? Just now before, if you check here, see, we maintain temperature and we maintain pressure and we used the catalyst. These are the compulsory conditions in Haber's process for the preparation of ammonia. So, which conditions are suitable for the production of ammonia by Haber's process? High pressure, high temperature, use of catalyst. See here, 450 degrees Celsius is the high temperature, 200 atmosphere is the high pressure, and here we used the catalyst is